Hello everyone, welcome to the video lecture series on double integration. I am Mayur Gohil. In this video lecture, we will be understanding how to see the curves and its equation in different forms. Okay, let us first consider a curve of a standard circle. Now, over here, you see the circle whose equation is x square plus y square equals to a square. That means the center is at origin. From the diagram also you can realize that the center is origin and the radius is a. Alright. So now the question begins is that how can we associate the equation of circle to these semicircles? Because if you observe over here the semicircle 1 and semicircle 2, if you take the union of both of them, you can get the circle back again. Then if you see the diagram 3 of the semicircle and the diagram 4 of the semicircle, if you take the union or join them in a layman language, you can again get the circle. So that means that each of the equation of these semicircle should be associated to this standard equation of the circle that we see. But how? That's the question. And there lies the key of understanding. If you solve this equation a little bit further, let's say if I write this y square equals to a square minus x square, and then if I take the square root on the other side, we always take plus and minus while taking the square root, right? So it means that there is a positive part as well as the negative part. Those are going to play an important role over here. Let me show you. The equation of the first semicircle over here is going to be y equals to square root of a square minus x square. Okay? Now it's a positive square root. And the equation of this semicircle, the second one, is going to be y equals to minus of square root of a square minus x square. How do we get this? Now, this is what the key of understanding over here. What it means is that, see, as x-axis, x can take any value, positive or negative, alright? Because of that, here the square is lying, so positive and negative values are not going to affect the equation over here. But what is going to affect, if you see the diagram is saying that it's on the upper half of the plane, right? It's on the upper half of the plane or above x-axis. Because it is above x-axis, that means y is always positive. So that's the reason you have y equals to positive square root of a square minus x square. Okay. Now, another thing, same way the similar logic follows in the second diagram. That is, because y is having negative values, you are going to have y equals to minus of square root of a square minus x square. Now, with the parallel argument that I have shown you over here, can you try to write the equations of each of these two semicircles on your own? Pause the video for a moment and try to write for them. Try to write their equations. Alright, so I'll take a pause and even you pause the video so that you can write down, think about the equation of each of the two semicircles over here and write them down. Alright, I hope you have worked on it and written as follows. For the third semicircle that you see is going to be x equals to minus of square root of a square minus y square. And for the fourth one, it's going to be x equals to square root of a square minus y square. over here it's the positive square root. All right. Now this crucial understanding of the circle and the semicircle, because semicircles are the one that make up the circle, is the key of understanding this shapes and the curves over here right now, and the equations associated to it. You can obviously see that each of the four equations that you see is a part of the original one, x square plus y square equals to a square. Now, this is where you can see there is a connection between the geometry and the algebraic equation. Otherwise, while solving, you just tend to solve it very quickly and you just do not have a glance of what is the geometrical interpretation. But yes, now you can clearly understand that each part, whenever you take positive, negative square roots, there is a meaning to each of them. As far as if you have a geometrical understanding of that topic, or if any geometrical concept is attached to it. Okay, let me give you one more thing for brushing up your knowledge on circle. We know that if h comma k is the center of the circle and a is the radius, then the equation of the circle is given by x minus h the whole square plus y minus k the whole square equals to a square. All right. Using this equation itself, you can see that the center of the equation x square plus y square equals to a square is origin. Okay, it's going to be 0 comma 0. All right, so let's go further, like take up a new curve over here. This is the parabola in front of you. It's a very standard parabola opening in the top direction towards the positive direction of y-axis. Its equation is given by y equals to 4ax square. All right, it's one of the standard parabolas that you have studied. Now, in the same way, on the similar lines, I show you the same parabola but broken into two parts. Can you write down its equation? What is the equation for the first one? This is where the understanding point of the curves and its equation is hidden. It's very intuitive, but yes, it's strong enough. You have to give a reasoning along with it, but it's just for understanding purpose right now. So for the first parabola, you observe that all the values of x are positive. It's in the first quadrant, right? So all the values of x and y are going to be positive. That's why you have over here the equation as x equals to square root of y upon 4ax. Y upon 4a. Now, what about the second parabola? Over here, second part of the parabola, you can observe that here x is negative and y is positive. The parabola is lying in the second quadrant. So what is going to be the equation? It's obviously x equals to minus of square root of y upon 4a. All right. So you have seen these types of curves now, and now I motivate you to draw the curves on your own, different forms of parabola, ellipse, hyperbola, and try to find what part of the parabola will be having the semi parabola or semi ellipse. What are their equations on their own? Try to find out you once you have understood all these concepts. Okay, so try to do them on your own. Now, the remaining part of the topic is again an advanced part. It's a little bit theoretical, more in nature. So we will see it in the next video lecture. Till then, keep solving good amount of mathematics. Thank you.